Okay. So sine A over A is equal to sine B over B, and that's chosen because we have the B's. And since we have the little a, then we can solve for capital A. To isolate the sine A, I'm multiplying both sides by A. It gets us to here. That implies that, well, I guess we can show the step. So we get to here. Once you get there, use your inverse. So capital A is equal to sine inverse A sine B over B. These are technically formulas because I keep solving for them in general. So you could use these technically. But anyway, plug in the numbers and we're good. That'd be 10 sine 50 over 4. So punch this in and see what happens. So the top parentheses divided by the bottom in parentheses. You should get an error. So I should tell you right away. It's a domain error, actually. There is no triangle to stop at this point. So basically we have something like, where's my picture? Yeah, something like this. But just kind of stops. See what I mean? You try to find this angle, but or that one, but it doesn't exist because it never closes. So there isn't a triangle. Anyway, any question on the last problem in 8.1? We're going to go to 8.2 in just a second. I just didn't have time last time. In the next section, I'm going to give you all the formulas that you're going to need for log cosine. Some of those formulas are not in the book. I simplified them for you. That way, all you got to do is plug stuff in, and you'll find your angles. Super easy. So I recommend you have these written down somewhere on your formula page or something, or just make a note of it that you'll come back to it. But you guys cool on an example 4? That's all right. Okay. So I'll wait a bit. All right, 8.2. Law of cosines. Remember, we said this is for case 3 and 4. When case 4 was when you have nothing besides. Case 3 is when you have angles, but no opposite side to those angles, which means you cannot use sine. Okay. You can use law of cosine whenever you want, but you have to use it when in those 2 scenarios. Okay. The good thing about case 3 and 4 is you don't have to worry about multiple triangles. You just solve it. Okay, because think about it. Case 3 is giving you two angles, so that means there is a triangle. Case 4 is giving you 3 sides, that means the triangle exists. So there's no way a second one will appear, or you'll have no triangle because it's just there. Okay. So here is the law of cosine. So given some general obtuse triangle. Okay. To find sides, use the following. This is the first set of formulas for law of cosines. So lowercase a is equal to the square root of b squared plus c squared minus 2bc cosine a. That's 2 times b times c times cosine. So you have to do this all together. Okay, don't subtract these things and then do cosine. You know what I'm saying? Do your PEMDAS. Someone always does that, so I'm just warning you.
To do what?
Don't subtract these. You see how a lot of people will be tempted to do b squared plus c squared and subtract 2bc. Like you can't do that because it's attached to cosine. It's times. Okay. Just reminding you. People forget for some reason. B, very similar. A squared plus c squared minus 2ac cosine capital B. Little c, that'll be a squared b squared minus 2ab cosine c. Okay. Now I'm gonna give you the simplified version for the angles. So these are the ones I did myself that are probably not in the book. So capital A, if you just want to find angle A, you need all three sides. Okay, so you got to find the side first if they're not given. So it's equal to cosine inverse of all this garbage. B squared plus C squared minus A squared over 2BC. Oh, wait a second. Capital B. It's A squared plus C squared minus B squared over 2AC. Is equal to A squared plus B squared minus C squared over 2AB. So you can find any angle using law of cosines given that you already have the sides or you found the sides. That if one side is missing, you can't use any of it. You'd have to probably go up here and use these first. Okay. Depends. We're assuming, of course, that we're case 3, case 4. As real quick, I'm going to give you one last formula. My pre-cal teacher told me it was pronounced Hero's formula, some Greek guy from a long time ago. It's a formula for area. It's spelled Heron, though. So area is equal to the square root of S times S minus A times S minus B times S minus C. And S is defined to be 1/2 times all the sides added together. A plus B plus C divided by 2. So given all the sides, you can find the area for any triangle. Okay. All the old school formula used to use 1/2 base times height as only for right triangles. So we're not dealing with right triangles. That's why all the formulas are more complicated. Chapter 8 is all about non-right triangles. Start an example in a second. Okay. Let's go on this page. All right, example 1. First one for 8.2. Solve the triangle. They give us one angle and two sides. But notice how none of those sides are opposite to the angle. So that kind of that's what messes us up. Gonna put it over here to the side of the stuff we want to find. Do you see why we have to do law of cosines? We have no choice. So given those formulas I just gave you, what would you choose to find first? I'm not going to tell you, so what do you think? If this was a test question, how would you start? Yeah, we should find the missing side first, right? Because once you have the side, you can do all the angles. If you look at the formulas. Look at the formulas right here. They all require all three sides. So find the missing side and it'll be good. We're going to need this guy. Okay, well, let's do it. So step one. Find little b. Little b is equal to the square root. A squared plus c squared minus 2ac cosine b, right? Yeah, I think so. Plug it in. And so formulas are simplified. All you got to do is plug stuff in. That's 10 squared plus 12 squared minus 2 times a times c cosine 30. Well, I guess at that point we should just plug it into the calculator. Make sure you're in degrees. Should come out to like 6 something. $6.0128. Or around to, I don't know, 6.013. Okay, so there's little b. We found this guy. So now we just find the angles. Get all three sides. Let's plug in the formulas. Step 2. Find angle A. Capital A is equal to the cosine inverse. A bunch of stuff. That will be cosine inverse of 6.013 squared plus 12 squared minus 10 squared two BC would be 2 times 6.013 times 12. So just do the top in parentheses and then the bottom. Or do the fraction button. Oh, man. Oh, I see. There should be about 56 point, I don't know, on a 1 decimal place, I guess. But once you have 2 angles, you can find the third, right? It's no big deal. Just subtract from 180 and you're done. You could use a formula one more time if you want to, but that would be unnecessary. So C would equal 180 minus A minus B, which is 180 minus 56.3 minus 30. It's about 93.7. Any questions on any of the steps? Does that seem doable?
You did, for NE, how much could you do?
Okay. So basically, let me just redo it here. So if you're not using the fraction button, open like a step at the top and then start. So 6.013 squared plus 12 squared minus 10 squared. So that's the top part. So close it off. Then divide and open a bottom parentheses. That's 2 times 6.10013 times 12, close the bottom, and then close the cosine. Yeah, whenever you see a fraction, just remember top part, bottom part. You'll always be good if you separate them. Okay, so that was case 3. Let's do a case 4 where all you have is sides. Solve the triangle. Okay, so A and B and C were not given. Only the lowercase sides are given. So this shouldn't be too bad. You just straight up use the formulas, find two angles, and then subtract from 180 and you'll be done. So find A first. A is equal to the cosine inverse of B squared plus C squared minus A squared over 2BC. So that is cosine inverse of, let's plug it in and then that's it. 25 squared plus 18 squared minus 20 squared, oops, over 2 times 25 times 18. So plug it in and you should get an angle of about 52.4. Okay. Capital B is cosine inverse of A squared plus C squared minus B squared over 2AC. Don't know why I wrote that again. So plug them in and you'll have 20 squared plus 18 squared minus 25 squared over 2 times A times C. Should be 82.1. Yeah, 82.1. So see, when you have the size, it's not too bad, right? Just find two angles and you're pretty much done. C will simply equal 180 minus A minus B. So that will be 180 minus 52.4 minus 82.1. Any questions on number 2? Okay. So in this section, you'll either have case 3 or case 4. Let's do a word problem and an area problem. Let's make a note here. This was case 4. This one was case 3. Distance of a boat. All right, suppose a boat leaves port and travels 10 miles. Then turns 20 degrees and travels another 8 miles. How far is the boat from the port? So try to picture this. I think the best way to do is draw what's happening and create a triangle. And it can be drawn many different ways. I'm gonna draw the simplest way I can picture in my own head. I see, let's say I'm at port over here. And I just leave for 10 miles. And suddenly I decide to turn 20 degrees this way. So I'm out here. So this, I go 10 miles this way, right? Then I turn and go 8. So use your triangle pre-cal powers here. Find out how far you are from the port. In other words, find out X. Now, something I need you to picture is if this was straight, right? This angle here is a 20-degree turn. Right? So what is the inner angle? Because I need this angle in order to solve for x. This is 20. What is this one? Yeah, it's going to be 160, right? Because a complete turn is 180. So this piece would be 160. So now that I have all those pieces, you can just use that formula for the missing side. All right, so x would equal square root of 8 squared plus 10 squared minus 2 times 8 times 10 cosine of 160. It's basically one of the side formulas. That's it. But you couldn't use it until you found that inner angle. Everyone see how we found the 160. You plug that in, you should get about, remember this is in miles. It'd be 17.7 miles. Should be. Any questions on example 3? Is that okay? Not too bad. Okay. One last example. You guys cool on that page? Okay. Use Hero's formula to find the area. So in an exam, what I'm probably going to do is say, you know what, find all these missing signs and angles and then give me the area. For this one, I'm just going to go ahead and give you the sides just for the practice. So area, we said the formula is equal to the square root of s times s minus a times s minus b times s minus c. There's a couple other area formulas, but I like this one. It's just straight up. You just got to find the sides. Okay, if they're not given, find them. So let's find s first. S is defined to be 1/2 times a plus b plus c. Which is equal to 1/2 times 10 plus, well, what is a? A is 10, 15, 7. So that is 16, right? It's 2232 divided by 2. Yeah.
Right. Lowercase letters for the.
What's for the sides? Lowercase will always be sides. So at that point, just plug everything in and you're good. So this would equal 16 times 16 minus 10 times 16 minus B is 15 times 16 minus 7. The order doesn't matter, I'm just trying to be consistent. You can put them wherever you want. A, B, C first. Who cares? So that will be the square root of 16 times 6 times 1 times 9. Whatever that is in your calculator. $29.4 squared units. They didn't tell us what they were, so some squared unit. We're talking about area. Anyway, any questions on number 4? Let's use the rest of the time to do some homework. If you have questions, let me know. I'll take roll on a bit.